Hello everyone, today we'll be talking about the digital genome. My name is Stephanie Fung and I hope you enjoy the presentation. So genetic databases are not new. We've had ancestry DNA databases, medical genetic databases, and law enforcement DNA databases, among others. However, historically speaking, there has been a natural separation between these databases because they tend to contain different types of genetic data. For example, medical genetic databases typically screen specific genes, and this data is usually not variable enough to be useful in law enforcement. Additionally, some databases have specific rules. For example, there's a law that limits who can be included in law enforcement DNA databases. But all of this is changing. The unit of genetic currency is becoming the same thing, the sequence of the entire human genome. So what is a genome? A genome, as the definition in the dictionary states, is a complete set of genes or genetic material present in a cell or organism. So to us computer scientists, the human genome is essentially the source code of a person, which is kind of cool if you think about it. So in the past, the first sequencing of the human genome, which contains 3.2 billion base pairs of DNA, took many years and cost tens of millions of dollars. Today, your personal genome can be sequenced and digitized in minutes for a few $100s, and the results can be saved on a USB stick and easily shared. So what does this mean? Many of our biggest health challenges have a genetic component. For example, cancer is best described as a disease of the genome. With digitization, doctors will be able to identify a patient's tumor's genetic makeup and use this personalized info to make a treatment plan. This new knowledge is making precision medicine possible, which means creating highly targeted therapies that can improve treatment outcomes. This new ability to rapidly and cheaply determine a person's unique genetic makeup promises a revolution in a more personalized and effective healthcare. So here you can see a short summary. According to the rankings of the World Economic Forum, we can tell that the digital genome technology has a high chance of being mainstream in a few years and will affect healthcare and its surrounding economy significantly. But it also has a high risk factor due to data misuse, which brings us to the next point, the main ethical issues of this technology. First and foremost, we have privacy concerns. Like all personal information, a person's digital genome needs to be safeguarded. But unlike most personal information, your genome reveals intimate data not only about you, but also the people who you're related to. Because of this, concerns about collection, transmission, storage, and use of this data is even more important. The problem is, keeping the databases separate and anonymous is incredibly difficult to accomplish. It's already possible in some cases to use a complete genome to locate an organ donor by searching through publicly available ancestry databases. Not only do we have privacy issues, the impact that this technology will have on our society is significant. In the smaller scheme of things, people's reaction to the risk of genetic diseases has the potential to cause mass panic or cause them to react in less than appropriate ways. There's also the possibility to de-anonymize genomic data using facial reconstruction in the future when AI technology becomes more developed. It's also possible that the future might lead to genome sequencing being a mandatory routine screen at birth. But this technology will not only affect individuals. In the grand scheme of things, it will affect the world. Laws will become ethical dilemmas. Who can access this data, how, when, and why? These privacy concerns are made even more apparent when you realize that at this point in time, legislation protecting consumers from genetic discrimination is essentially non-existent, since a person's genome contains data about their health and what medical conditions they are most likely to suffer from. Employers and insurance companies will want access to this information, it could affect how they treat you, and that is discrimination. So how do we decide what laws are just? The predictive power of the genome is only going to increase over time, making the information more valuable the more accurate the results get. Once a consumer has taken a genetic test, they may be required to disclose that fact to an insurer or risk fraud charges. Australia is a country who is not averse to mass surveillance, considering they have a national facial recognition system, and they're proposing mandatory DNA collection from all newborns in Australia. Law and enforcement and private companies are pushing for access. You can get in contact with a direct-to-consumer DNA company and pay them to digitize your genome for you. However, these companies can be legally required to hand over customer data to law enforcement, and their privacy policy that consumers agree to make it impossible to know who else will have access to the data. Plus, digitized genome has monetary value, and genetic data from these companies have already been sold to pharmaceutical companies. All of this points to the fact that laws surrounding this technology could easily be non-ethical, and there is no real solution to preventing this. Despite this fact, the potential good that this technology can do has never been seen before, and that's why it's important to talk about these concerns and figure out solutions at present. Now that we've talked about the main ethical dilemmas, let's talk about the main stakeholders. The biggest player is the government, with a plural S. Countries like the UK, Canada, France, US, China, Australia, etc. are all undertaking massive genomic projects. As mentioned before, Australia is planning mandatory DNA collection of newborns, possibly of all Australians. The US National Institute of Health has launched a precision medicine initiative that aims to combine genetic and health data for 1 million people. China is investing more than $9 billion USD for something similar. Other large players are private companies and pharmaceutical companies. Private companies like Human Longevity Inc. is planning to sequence 1 million genomes by 2020 and has partnered with pharmaceutical giant AstraZeneca to work towards this goal. There's also direct-to-consumer DNA companies, as mentioned before, where you can go to get your genome digitized. And in the future, big block retailers like Walmart or Amazon will most likely take an interest in selling relevant items. Already, Amazon, who claimed 45% of online sales on a random Black Friday, reported a DNA testing kit as one of its top 5 best-selling items on that day. That's significant and proves that this tech will be a big part of the future. Right, it's time to apply some ethical theories to some of the dilemmas mentioned previously. Now, normally I would start with Kant, but in this case, I'm going to argue that if the world was perfect, if everyone followed the categorical imperative, then none of this would be an issue. Digital genome technology would be amazing to save lives and revolutionize what human beings are, and there would be no privacy concerns because no one would look at information that isn't theirs, and laws wouldn't even be necessary because everyone would follow the same moral compass. Okay, I might be exaggerating a little bit and glossing over things, but my point still stands. Kant is all about a shared moral community and treating everyone equally and properly. So in his perfect world, there would be no moral issues. Leave me a comment if you disagree, if I missed something, or if I'm just plain wrong. I'm happy to hear your thoughts. On to a slightly more serious note. Let's talk about utilitarianism. Utilitarianism is all about a scale. So unlike Kant, we're less focused on the intent and more on the consequences. So if we talk about digital genome technology as a whole, focusing on the weighted pros and cons of our ethical dilemmas, this is what we have. The 3 main ethical issues, as stated previously, are privacy issues, the impact the technology has on individuals, and the problem with deciding just laws. So these 3 things that I've listed are all cons. Privacy issues affects individuals and the people they're related to. But it's difficult to quantify who exactly is affected and if they'll even be affected. There's no data for this, and since utilitarianism focuses on the consequences, if we want to make a judgment, we have to make an assumption. The educated guess in this case would be to assume that no one's privacy will be kept. If one person in the family digitizes their genome, this data is relevant to everyone else in the family. So on a bigger scale, since we're all related to one another at some point in the family tree, then everyone is affected. Next, the impact on individuals. So you are directly impacted if you digitize your genome. Not only this, but your reaction will likely affect the people in your circles, whether genomes become a conversation topic or the result cause any other event. It's safe to assume that this would affect most people. Whether the impact is positive or negative remains to be seen, but assuming it's a 50-50 split, then we can zero this out of the calculations. Last is the dilemma of creating just laws. Ideally, the laws created would be just, but at present, we don't know exactly what's going to happen here. To summarize what we just talked about, here are two tables for the pros and cons of the digital genome technology. There is a problem though. To take advantage of this technology, you have to get your genome digitized, which means the cons come with the pros. And right now, it looks like the cons are outweighing the pros. However, we haven't considered the most important pro yet. Lives could be improved and even saved. The whole point of this technology is to improve the medical field. Utilitarianism doesn't care about the intention, but in cases like these, where technology has a huge potential to do good but also to do harm, it's very difficult to come to a conclusion with all the missing data. So, does utilitarianism consider the digital genome technology to be good or bad? We can argue either way, but we can't give a concrete answer at this point in time. This is why considering ethics is important when working on cutting-edge technology. When we can't figure out if something does more good than bad, it's crucial to put measures in place to maximize the good while minimizing the bad. In this case, that would be advocating for just laws to be upheld. Since we're talking about rights, let's talk about John Locke. Remember what he believes, specifically his views on ownership. He believes that we all have rights over our own bodies, our labor, and the products of our labor, and that none of this is given to us by the government. Consider our genomic data. Back to the issue with laws, how do we decide who owns this data? Does it belong to the person or the company who digitized your data? There's no clear legal owner. You can't patent this data, and you can't copyright it because it lacks a creator. Imagine source code of a human being. Who wrote it? Okay, that's enough food for thought. Let's talk about our role as a computer scientist. There are two ways to ask this question. How would you deal with these problems as a computer scientist? But also, how can you contribute positively? Currently, there are two approaches that are being explored as a way to give people control over their genomic data: blockchain and genome cloaking. So why blockchain? Blockchain has been built around privacy, security, and ownership. It's virtually impossible to hack, which makes it the perfect solution for keeping your genomic data safe. Remember that blockchain uses a ledger to keep track of all the changes made to data. That means if you hack one node, the remaining tens of thousands of nodes will immediately reject the manipulated records. However, not only can it hide sensitive information, it can also make the information anonymous, which is very important because this anonymized genomic data is vital for scientific progress. Like we mentioned before, personalized medicine is only possible because we're able to analyze genomic data from a large sample size and use it to create better treatments and do research on genetic diseases. So philosopher David Kopsel has been pushing the frontiers of ownership and protection of genomic data for nearly a decade. He's authored many publications about genomic data and privacy with his longtime collaborator and partner, Dr. Vanessa Gonzalez. His book, Who Owns You?, foreshadowed the lawsuit against a corporation that was trying to patent a set of genes that, if granted, would allow them to monopolize the testing market for breast and ovarian cancer. So he was right about the lawsuit, but that made him think about something critical. If individuals don't legally own their genomic data, how can we best ensure its security and privacy? So he started a software company with Dr. Gonzalez to solve the problem, called encryption. In an interview, he said, "People have been thinking about using blockchain for genomics for a while. We just wanted to do it a certain way, and first to maximize the ethical safeguards we think are most important." He's revealed that the major obstacle for everyone is time. A raw genomic data file is typically about 6 gigabytes in size, which is quite large. And the processing of blockchain data is typically very slow, and with these large data sets, progress is even slower. And since human genomes are 99.5% similar, we can ignore the similarities and just focus on the differences. Encryption uses deep learning techniques to compress the data, making the dataset smaller and easier to work with. The idea behind a genomic blockchain is to make it a safe space to store an individual's genomic data. Encryption created the gene chain, which is essentially a DNA database marketplace that connects individuals with interested buyers. The data stored on this blockchain is encrypted and virtually unhackable. Encryption also tracks misuse, with each data's unique signature. On the gene chain, owners can store their genomic data for free and choose which parts of their genome to share using a time-limited key. Buyers can access the metadata, which contains anonymous basic information, and then contact the owner of this data to get permission to access. Owners don't need to share the data with only the buyers in the market. They can also share it with their own personal doctors. The important thing to take away here is that this system gives an individual full control of their genomic data. This way, both parties can go through proper ethical procedures that may be unique for every jurisdiction, and it makes negotiating terms easy. Research institutes or companies who use large amounts of genomic data can purchase these licenses without worrying about the ethics, which is already baked into the product itself. The other approach that is being used to keep genomic data private is genome cloaking. It's a technique devised by biologists, computer scientists, and cryptographers that scours the human genome for only the relevant genetic information necessary for a study. It can hide up to 97% of an individual's unique genetic data. 2 graduate students, Jagadish and Wu, adapted a cryptographic approach with cloud computing for use with human genomes. The idea is for an individual to encrypt their own genome using a simple algorithm that they can run on their own device, and then upload this encrypted information to the cloud, where the researchers can securely access it for analysis. The encrypted data describes the presence or absence of the gene variants under study, meaning that private information in the genetic sequence is not revealed. To this end, only the individual will have complete access to their own genomic data. Ultimately, the goal is to find the best way to share information while also protecting each person's privacy. Now, how would you deal with these problems? Thanks for listening.